Let's solve for this system of three equations with three unknowns, okay? Three unknowns in this case, that means three variables. So what do we have? We have 2x minus y minus 2z equals to -1. Second equation, x minus 2y minus z equals to 1. Third equation is x plus y plus z equals to 4. All right? So then what we're trying to do here is to be able to solve for x, y, and z. And to do that, we're going to work two equations at the same time so that we can eliminate one of the variables and solve for two variables. Okay? And then we can solve for the third one afterwards. Okay? So that's the plan. But let's see how the plan works, all right? So we're going to screen these equations and then see which of the two of them we can pull out and work with, correct? And to do that, let's say when I look at this, I'm seeing -z and I'm seeing +z. In equation 2 and 3, I would say, bingo, this is the correct one. Why? Because I can simplify, I can eliminate z from here automatically. So what does that mean? Okay, that means I'm adding, so add equation 2 and equation 3 so that you can do what? To eliminate z. All right, so let's go for it. So 1x plus 1x is going to give us what? It's going to give us 2x. -2y plus y is going to give us what? -y. -z plus z, 0. But we do not need to put the 0, correct? And 1 plus 4 is 5. We're going to call this one equation 4. All right? So we call it equation 4. Okay. So then we have two variables here, right? So there's no more z. So now we're going to choose two other equations and do the same thing, okay? So then when we look at it, we have equation 1 here, -2z, equation 3 here, positive. So you always look at the variables that have what? Different signs, okay? That's easier to eliminate, okay? So equation 1 and equation 3 in this case. So what can we do? For equation 3, we just got to multiply by 2. Okay, so we just got to multiply by 2. So that means multiply equation 3 by 2. And then do what? And then add equation 1 to it. Okay, so that means when we multiply equation 3 by 2, what do we end up with? We end up with 2x plus 2y plus 2z equals to 8. And then we add it to equation 1. Equation 1 is what? Is 2x minus y minus 2z equals to -1. Okay? So once we have that, so what's happening? So this one is equation 3 that we multiply by 2, correct? So that's equation 3. And then this one is equation 1. Remember that, okay? So we keep that in mind. So what do we do here? +2z, -2z, out. Then 2x plus 2x is what? 4x. +2y minus y is what? Is +y. And then 8 minus 1 is what? 7. Okay? So this is what we have for 4x plus y equals to 7. We're going to call this one equation 5. Okay? We see then equation 4 we have x and y. Equation 5 we have x and y. So what does that mean? We're going to solve for x and y first. And then we can, bring out z afterwards, correct? So then we have 2x then minus y equals to 5. That's from equation 4. And then I have 4x plus y equals to 7 from equation 5. I can combine them together, so I can use additional elimination method here. That's the easiest one in this case. -y, +y, crossed out. 2x plus 4x is what? Is 6x. 5 plus 7 is what? Is 12. And then I can divide by 6 and 6, both sides. So x equals to what? 12 divided by 6 is what? 2. So I end up with x equals to 2. Okay? So once I have that, what then is happening? I can solve for y. So to solve for y, I go in one of these two equations. Doesn't matter which one you choose. In this case, because I have y, which is a positive in this case already, so I can just choose equation 5. Okay? So I'm choosing equation 5 in this case, so that's 4. So x is what? Times 2 plus y equals to 7. So that is from equation 5. Okay? So 4 times 2 is what? Is 8 plus y equals to 7. Then I can just do what? Negative 8, both sides. Then y equals to what? 7 minus 8 is negative 1. So y is negative 1 in this case. Ladies and gentlemen, you see what's happening? So we have x now, we have y, now we can solve for z. To solve for z, we go back to the original equations. We choose one of them, only one, and the easiest one to use at this point. Okay? So for that, I would choose equation 3. Why? Because there's plus 1 here, plus 1 here, plus 1 here. All of them have coefficients as 1. So that's the easiest one, and positive one especially, easy to go with. So that means I'm having x plus y plus z equals to 4 from equation 3. Okay? So what does that translate to? X is what? Is 2. So I substitute it, plus y, which is what? Negative 1. And because that's negative 1, we can take this one off. Plus z equals to what? Equals to 4. Okay? So that means we're going to combine 2 minus 1, which is 1, plus z equals to 4. And negative 1, both sides, because I'm solving for z, then z equals to positive 3. And because z equals to positive 3, my overall solution is x, which is 2, y, which is negative 1, and then z, which is positive 3. And ladies and gentlemen, you are finished. Okay? So you take your time, step by step, go through the equations, screen them up, take 2 out, which are the 2 that you can work with, eliminate one of the variables, solve for the other 2 variables, like how we did it here. Equation 4, equation 5. Take them out, solve for x, solve for y. Once you have x, you have y, substitute it back into one of them. Only one of them. And the easiest one in this case had to be equation 3. And then, ladies and gentlemen, you are finished in this case. You're done. This is great. Fantastic. All right?